Okay, as advertised, we're going to do y equals 2 to the x. I've already set up a table, same as I set up any other table. So we want to start with x equals negative 2. So we're trying to find y, which is equal to 2 to the x. When x equals negative 2, that's going to be then 2 to the negative 2. Now if you did what I asked you to in the previous video and made this table, you might well have gone to a calculator and punched this in. And you would have seen that if you punch in negative 2, 2 to the negative 2, you're going to get 1/4. Well, we're not talking about constructing these graphs with a calculator. We're talking about constructing these graphs with no aids whatsoever, just a blank sheet of paper and something to write with. Okay, no calculator, no notes, just start from scratch and sketch the graph. Okay? You don't learn to understand the function by, you don't learn to understand the arithmetic by punching the calculations into a calculator. Okay? You don't begin to understand why the graph has the shape it does by using a calculator to do the arithmetic. Obviously, there are places where you would need a calculator. Okay, and as a matter of fact, to evaluate this function when x is negative 1/2 or 1/2, you just about need a calculator, because the answer doesn't come out very nicely. It doesn't come out as a rational number, actually. It doesn't come out as anything you can express exactly in decimal notation. So, there's certainly places where the calculator is appropriate, but we're not going to be using it to construct these graphs. And we're not going to be using the calculator much at all in this course to do our graphing. We're going to graph by first principles, so we develop a deeper understanding of the functions and what we're doing when we construct our graphs. Okay. Well, 2 to the negative 2. What's 2 to the negative 2? Well, here's where we might have a problem. You're used to doing this by calculator. There are laws of exponents. Okay? Very, very seldom do I see a pre-calculus student at the beginning of class who knows the laws of exponents. Almost nobody could list them all, and very few people know when to apply them in certain circumstances, and this is one of them. Okay? What's 2 to the negative 2? One of the laws of exponents tells you that. Well, the law of exponents that applies here is this one. A to the negative b means 1 over a to the b. Negative exponent means it's a reciprocal with the absolute value of that exponent. But that's too many words. You get the idea just by doing it, and by doing it without punching buttons. Okay? 2 to the negative 2 then. If I apply this rule, what's that going to be? You should think that through before I write it down. Well, okay, by this rule, hope you thought it through before you watched me do it, because you learn more. 1 over 2 squared. And that is 1/4. And that's why your calculator tells you 1/4. Okay? What's 2 to the negative 1? Well, by the law, that's 1 over 2 to the 1, which equals just, since 2 to the 1 is 2, that's just 1 over 2, 1/2. And then, what's 2 to the 0? What is 2 to the 0? Think it through. Tell me what you think it is. No calculator. You got to know the definitions and the laws. Okay? Well, one of your laws of exponents is that any number raised to the 0 power is 1. Many people, maybe a majority, will tell me that 2 to the 0 is 0. Okay? I could and often do talk about the terrible deficiencies of mathematics education as it's taught across the country. But that's well acknowledged, and it's just that nobody knows what to do about it. And I don't pretend I know what to do about it. Okay, it's terrible. Don't know how to get out of this. Hopefully the people who are in a position to do so will do so. Okay. Then, if x is 1, 2 to the 1 is just 2. And if x is 2, 2 to the 2, 2 squared is 4. So we're going to get 2 here, 4 here. I'll leave question marks here. Now 4 significant figures. This is 1.414 into 3 significant figures. I believe this is 0.707. I know the 2 significant figures it's 7.1. Pretty sure it's 707. Doesn't round to 708 or 706. But I'm not 100% sure of that. Okay. And you could use your calculator to get this. Or take the reciprocal, the 1.414, which nobody seems to know. But in any case, we draw our axis. We're going to put 0 here, 1 here, 2 here, -1 here, -2 here. Sketch our y-axis. We're going to need numbers as big as 4. So here's 4. We come down here. Maybe I got 2 in a good place. I don't know. 3 here. 1 here. Okay, now I'll plot my points. Okay, -2 goes with 1/4. Cut 1 down to 1/4. You're about here. So I'm going to say we've got a point about here. And then -1 gives us 1/2. So, here's a half. So twice as high as a fourth, half as high as 1. And 0 gives us 1, so we're going to have the point 0, 1. That's this point here. And then 1, 2. So here's 1 and here's 2. I hope I'm getting these fairly close. I don't want to get over here right in front of the board and block it completely. And then 2 gives us 4. And there's a sequence of points. And if we want to sketch a smooth curve, it might look something like this. Okay, well, that's 3 of our functions. The other 2 functions are y equals x cubed and y equals 1 over x squared. Okay, the x cubed graph is done using the same rules that we use to evaluate this. Okay, you got to be careful when you evaluate it, so I'm going to kind of leave it to you to evaluate it. Evaluate it by hand, not using a calculator. Make sure you understand why each number gives you what it does when you cube it in terms of the rules. Okay, and 1 over x squared has a lot in common with 1 over x. And again, there are some differences. You've got to be sure you understand the rules in order to do this with any kind of confidence. And by the time you learn to do all these evaluations and construct all these graphs, each in a minute or less, you'll have a much better idea of the rules and how they work, and you'll have a much better feel for why the functions have graphs with the shapes that they do.